finishing up plate boundaries and the models and tectonics, which I'll make a separate video to make sure that I have enough time. Don't run out. The last time we had class, we did the convergent plate boundaries. Right? This is the picture that's from my friend's book on classroom. So you pull it up and go ahead and copy that down to compartments. The explanation is on the previous video. Today we added divergent plate boundaries. So if you can't draw the paper that was on classroom, it's really simple diagrams. You can just draw them in. And I advise using the same colors, at least for the drawings that I did, to reinforce. Water is blue and brown is green, magma red. So it just helps your brain learn. So when you finish class, go ahead and draw it in. This is divergent, which is the opposite of the last time. Convergent. Di, in this sense, means to pull apart, like when you dissect something. Verge is still edge, so the edges are going apart. So here we have an oceanic boundary. So since it's down in the elevation, it's closer to the mantle and where the magma is. And that hot magma, because convection is going to go up, and it's going to make its way through this crack, this opening, as these plates move apart. But when that hot magma hits the cool ocean, it cools off, and it solidifies and makes things stronger. Then the plates move around some more, and more magma comes up, maybe it'll go a little higher, cool off, eventually. If the elevation of the seafloor is enough, it will make something come up above the water, like ice. So all of this makes it a long mountain chain known as a ridge. So think about like down your spine, how you feel your different vertebrae. Okay, it's in the middle of the ocean, the knee, and then ridge with a long, drawn out mountain. And you got something like a piece of paper here. If you look at it like this, it looks like one mountain. But when you turn it sideways, it's longer. That's more like a ridge. Okay? You'll find these in the middle of some oceans. We'll look specifically at our example of the Mid-Atlantic Ridge. It kind of looks like a scar or a fracture down in the middle of the Atlantic Ocean. You can see below the water. Things you need to know is that the closer you are to the ridges, the younger the rock. That's the baby rock. It's being formed. And it gets pushed off to the side as the plates move. So the further you go away from the ridges, the older rock. Here we've got grandpa, in fact, convergent. The grandpa rockets is the one that's more dense because they shrunk with age, and they're the ones that are going to be subducted and melted. So you can jokingly call the baby rock the grandpa rock. The other combo we've got is continental. And so basically you've got a giant hole in the ground, except it's not a hole, it's a long thing like a fence on it. So these are pulling apart, and that gap there is called a rift valley. With valley, the rift is a gap. Like when there's a rift in a relationship with someone, there's a gap between them. There aren't very many of these, but the best known one is the Great African Rift Valley. And remember, with these different land features on classroom, the previous week, so 15, where it says land features, there is a Google site here that will go through several of them that give you different images to help you out. And the next time I see you, Google Earth scatter hunt, so you'll look for some of them. Okay, but that's there to help you out. You can look this up and see the actual pictures of these places. Then, over time, this gets further and further apart. This ground drops more and more. It's nothing's holding up, so it will get wider and deeper. And water will always travel to the lowest elevation. So eventually, this will fill in with water and form what's called an inland sea. And within land. The third kind of boundary is called a transform boundary. Okay, so with your hands, we convergent, divergent. Transform is sliding past. You know how you rub your hands together to get them warm? That's sliding. You can feel the friction between your hands. That's what transform is. So convergent, divergent, transform. However you want to do your hands, sideways or like this. So trans means across, form means form or type. So it's going across its form. And there's different types of these specialty ones, but we're not going to get into that. This is great. I've just drawn some simple rectangles to represent two plates. And I just realized I forgot to write the plate names. So I'm going to tell you about how to fix in class tomorrow for this class period. So we got two plates, and where they meet, where the two boundaries are, that's called a fault line, okay, or a fault. In the United States, most famous part of us that have this kind of action going on in California with the San Andreas Fault. And when you hear about earthquakes on the news, that's where these are usually happening. We do have fault lines in San Antonio, but they're dormant, and they dormier. They're sleeping, they're not active. Like when you're heading towards Fiesta, Texas, you'll see the Balcones fault line go across 1604. Okay, but it doesn't work anymore. It's dormant. It hasn't shook in a very, very long time. If you feel shakes, that's the quarry down the road. Okay? But notice what they're going in the opposite direction. So it's not a head-on collision. It's not reverse. They're doing that sliding past. And that's going to cause these rocks. You know, these rocks are tons and tons of snarled, crackly rock that are, scraping past each other. It's going to cause stress, which is pressing, and tension, which is pulling on these rocks. And it'll build until eventually it'll give way. If we have a pencil, I can, I'm afraid my partner did pencil, but I can push, and it's taking it, and it'll finally snap. So remember that potential kinetic energy we did in the previous year. Right? And when that finally lets loose, it's going to release that energy in the form of an earthquake. But the process here, like we have a process of subduction and the other ones, this is called shearing. Which may seem like a strange word until you think about a pair of scissors. They would make like huge scissors that you use on sheep are called shears. Right? So if you have a pair at home, I would get them and actually pay attention to how they function. This is a lever. That's your fulcrum right there in the middle. But the sharp parts are on the inside, and they are not doing a head-on collision. When you look at them, they're actually sliding past each other just like the plates are. So that's where they get the term from, shearing. So know your three kinds of boundaries: convergent, divergent, transform. And then what kind of land features you'll expect to find there, and what processes are